Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. This is a continuation video. I know that on the previous video, guys, we talked about calculating the net electric field at a point, but only if the charges were just in one dimension or together. Right now we have our charges in two dimensions. Point X and charge A are on a horizontal dimension. Point X and charge B are on a vertical dimension. So these two are not in the same dimension. Are you together? Okay, before we even calculate the net electric field experienced at point X, whenever, guys, you are given a point charge, you must always assume that the magnitude of that point charge is 1.6 times 10 to the power negative 19 coulombs. And please, guys, always the time, please do not forget it's always a positive point charge. Okay, before I calculate, I must know how to find the, rather, I must know how is X going to behave because of A, and how is X going to behave because of B. Okay, between the two charges X and A, they are both negative. Yeah, they are both of them have different polarity, man, excuse me. Are you together? So there will be an attraction force between them. Are you together, guys? So point X will be pulled towards the right by charge A. Are you together? And then the relationship between X and charge B, X will be repelled by charge B, right? So it will just go like that over there. Are you together? But for us to calculate, guys, it's better if we draw our free body diagram like this. This is our vertical force. It represents the force between A and B, X and B, right? So remember that, guys, on the previous video we did state that electric field is always in the direction of the electrostatic force. Are you together? So if charge B pushes point X upwards, it simply means that the electric field experienced by X due to charge B will be upwards as well. Yeah? And then we'll start there to draw the force between X and B. Né? Since the force between X and B is towards the right, it simply means that the electric field as well is towards the right. Okay, and then this is our resultant force over there. That's my F net, or rather E net. Are you together? Obviously, guys, since I had 90 degrees over there, that means I will have 90 degrees over there. Are you together? I can find that angle whenever I'm calculating a direction, or I can find beta. It's up to me, guys. I will just show you how to express these angles. Okay, firstly, let's find the electric field at point X due to charge A. Okay, electric field at X due to charge A, it will be K multiplied by QA over R squared. This is just 9 times 10 to the power 9. The magnitude of A is just 2 nanocoulombs. That's 2 times 10 to the power negative 9, all over the distance between the two, just 0.2 squared. This will then give me 9 times 10 to the power 9 multiplied by 2 times 10 to the power negative 9, all over 0.2 squared. This will basically give me 4.5 times 10 to the power 2 newtons per coulomb. Are you together? That's newtons per coulomb. Okay, and then now let's find the electric field at point X due to charge B. It's still K QB over R squared, 9 times 10 to the power 9. The charge on B is also 2. That's 2 times 10 to the negative 9 all over 0.2 squared, and that will give me, it's not 0.2 man now, the distance now is 0.3 meters, né? So this will basically give me 2 times 10 to the power 2 newtons per coulomb. Are you together? So guys, remember that my free body diagram was like this, né? Over here I have a value of 2 times 10 to the power 2 newtons per coulomb. I have 4.5 times 10 to the power 2 newtons per coulomb. I want to find my E net. I have a right angle triangle. If that's my theta over there, I have both the adjacent and the opposite. I'm only looking for the hypotenuse. That means E net squared will be equals to the electric field at point X due to charge A squared plus the electric field at point X due to charge B squared. E net is basically equals to 4.5 times 10 to the power 2 all squared plus 2 times 10 to the power 2 all squared. Therefore, E net, I'll just take the square root on both sides. It will be the square root of open brackets 4.5 times 10 to the power 2 all squared plus 2 times 10 to the power 2 all squared. So this will basically give me 4.92 times 10 to the power 2 newtons per coulomb. Are you together? But you are not done. We just found the magnitude, né? But yes, I know that guys, 99% of the time they will ask you to find the magnitude. But let's say now they want you to find the direction as well. For you to find the direction, you must find theta first. How can you find theta? We can use any trig ratio we want, guys. We simply have 4.92 times 10 squared. We have both the adjacent, opposite, and the hypotenuse. You can use any trig ratio you want, né? If you want to use tan of theta, it will simply be adjacent over opposite. Which value is adjacent to the angle theta? This value is adjacent. It's next to theta, so it's adjacent. That's 2 times 10 to the power 2. And the opposite side, that's 4 times 10 to the power 2. Are you together? And then the angle theta will be the inverse of 2 times 10 squared over 4.5 times 10 squared. So my angle theta will basically be shift tan 2 times 10 squared all over 4.5 times 10 squared. And this will simply give me 24 degrees. Let me change this to normal, because I got my answer 23.96 23.96 degrees, right? So whenever guys we write our direction, now we know that the angle in between there, it's just 23.96. Are you together? So this is how you write your angle, né? Your direction. You simply say this is north. It's north because the direction over here is going towards the north. Are you together? It's north, but it's not going towards the true north. It's north, and then you simply say 23.96 degrees east. So this is the magnitude, and that's how you write the direction if ever you are given a two-dimensional problem. So that's how, guys, you deal with electrostatics in 2 dimensions. I really hope that, guys, the video helped you out. Just stay tuned and wait for more videos. Thank you.